I wonder if it's going to work its way up to this thing. Nice. Part 2. It's time for the Knights races. Unlike the Squires, they race on specially designed tracks that also affect the device's behavior, often disrupting planned actions. The track is organized as a closed loop of segments, allowing Knights to complete multiple laps. Knights start from segment S and proceed in a clockwise direction to the right when viewed from above. The terrain of the track is marked as follows. Okay. First action is executed, and the first essence is gathered at the first segment after S. The last action and last essence gathered for the loop occur at the S segment. S is the segment from which everyone starts, but is also the last segment of the track's loop. Okay. The race is set for 10 loops. Example based on the following notes. We have all of these plans. Oh, I see. The track is... Oh, the racetrack for the first round is shown below. So everybody has the same track, but we get a different input. This time it's 737 bytes. All right. Let's move downloads into everybody codes into input. And we're going to copy the track, input track. Oops, greater than. Okay. So there's the track. I guess we could do is just, for the first line, we just go along and go grab everything. And then we go down left and up. Because we're going clockwise. Right? Didn't it say clockwise? Somewhere? Yeah. Clockwise direction. Okay. Now we're going to need a track type. How big is this track? I just say this. Is it going to count each individual? So this is 71 characters wide. So 71 times 2 plus 2, 4, 6, 8, 10, 12, 14. Okay. And then we have to loop around it 10 times. Okay. Let's create a track type. Struct track. Do we need a track type? Because it's just a vector of actions, right? Oh. I guess we do want to distinguish. Let's rename this to equal and then name this to start end. And then we change this here to take that in. Okay, and then this is still correct. Oh, no. We have to change this. This alters. This says forces the device to increase the power by 1, ignoring the current action. So now we have to care. Okay, so maybe we do want a little impl on the track here. So the struct track is going to be track vec of action. And then impl track, we need to be able to read in I'm not sure the best way to do this, but I'm going to do it this way. Lines is equal to, you see lib read lines from input track. Okay. I just want to make sure we're doing everything correctly here. So part 2, I'm going to have this. We're going to get all the plans, but let's also do the track here. because I imagine we're going to use this for part 3 as well. Oops. Let's just do that for now. That way I can hit run over here and we can see all the track items. I see them there. Okay, so now we're going to run along each track or each segment of the track. Okay, this is going to be a little obnoxious. The first line is easy enough. Let track vec new. And this is going to be for action in lines of 0, iter, map. That's where it'd be nice to have this as a separate. I guess we don't need to do it this way, right? We can just say parse unwrap. Like that. And then these should be actions. I guess not, because I forgot that. Huh. It says unknown. Why? Oh, chars. Ah. Because they are chars, we need to map them from a char. And I haven't from a string for parsing. Do I want to say and do the same thing? Oops. Why did it do that? Oh, I hit 1. Unwrap type for type to type argument char instead of implement missing members. Okay. So this is this except with single quotes. Right? Oops. Oh, this now it doesn't take a result. So this needs to be a panic. I guess if I did a try from or something, it would work. Okay, so now we can do it that way. Here, instead of parse, we can say into. Oh, value. And this needs to be value as well. Expected 0 generic arguments. Really? Don't you have to tell it what kind of action, what kind of into to into? Really? Char as into action? Yeah, there's got to be a better way to do that, right? Okay, that fixes that part. All right. So this is the track, right? It's parsing it. There's got to be a better way to do this. If I say S char, but we want to map it to an action, I can say action from S, right? Yes. Okay. That looks better. And then we can say track push. All right. That does the first. That does the first bit of it. But that also means we can say vec action here, and we can say line action extend this. Oops. And say S into. I bet. Let's find out. Oh, track. Yay, okay. That way we get rid of the thing. But now we need to do the sides. Or the right side. So we got to start here and go all the way to here. So we're going to say, oops, or index in 1 dot dot lines len -1. We want to get this the last character of it. So let last char is equal to lines of index dot iter.rev dot, sorry, chars. Rev.take one. Can I say take one, or is there next unwrap? And now we can say track push last char into. And that should get these guys here. How do we verify that? I say here print len track. Ooh, there's the start end. Oops, didn't mean to do that. That's annoying. I didn't mean to do that either. All right. Oh, now it's over on the other screen. Okay. I'm just trying to get this on the edge here so I can compare the two here side by side. We have the start end. We have decrease, equal, increase, increase. Yep. And then here we should say decrease, equal, equal, increase, increase, equal, decrease, decrease. Ooh, there should be, yeah, there are 3 decreases. Okay. As we go around the corner. Okay. And now we want to go this way on this last line backwards. So this would be track extend lines of lines len -1. Chars rev map s into. Okay. Oh, I gotta put this here and see if that looks right. Should start with 2 decreases, a couple of equal signs, 4 increases. Yep. Okay. I think it's working. At some point, there should be 3 increases followed by 2 decreases followed by 2 equals. Is that here? I think that looks like there. Okay. And then we just need to go up from here to here. So we take these guys here. Oops. And we're going to go the other way around. Can I do this? And then we can take a look again and see if it goes decrease, equal, increase. Uh-oh, it didn't work. It should go decrease, equal, increase, equal, increase. Decrease, equal, increase. No, it didn't work. Let's take a look at what those last chars are. Oh, we don't want the last char. We want the first char. That's right. We get rid of that. Decrease, equal, increase, equal, increase. Equal, decrease, decrease, decrease. Okay, so I think we have the track now. Now the question is, how do we apply the track to plan? So let's use one of the examples. Right, we have this guy here. Test plan A part 2. And I think it's the same plan, right? So we get the same plan. There's tree in it. Okay. Oh no, this is a different tree. This is a test track. Okay, so maybe we pass in the input test track. Which means I gotta put up here input track. And then in track, we got to pass in and we need to pull in path. Okay. So if we run test, we should be able to print out the tree at this point. Oh, false, true. Oh, track. Why did I call it tree? Track. Can't print out tree. Track, sorry. I'm still calling it tree. Let's do that. All right, so does this equal, this is similar to the track we have here. Oops. Start, end, increase, equal, 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 increase, increase, decrease, equal, increase, equal, decrease. Yep, okay, so now we're just going to run around the track. What we'll do is we'll pass in to the track, execute plan, self, and plan, and it'll return the score. So it's going to be similar to what we did for part 1, except if the action is S or equal, then we don't alter the execution of the plan. Okay, let's see if we can do that. So this is going to be let mut cur is equal to 10, let mut sum is equal to 0. And then we want to go around 10 loops on the track. Okay. Right. For underscore in 0 dot dot loops, for index in, oh, wait a minute. We start on the track on position 1. We skip this bit here. Interesting. Because I can't just go 0 to, I guess what I could do is let track len is equal to self track len. I could do that. And I can say loops times track len. And we can grab +1, right? So let track plan is equal to self track of index mod track len map track plan or match. I don't know why that happened, but I must have hit the other one. Okay, so if it's increase, I'm going to say cur plus equals 1. If it's decrease, it's cur minus equals 1. And then anything else, action equal or action start end, we're going to actually go to the plan, which is, I wonder if I could just extract it from the plan here, because right now we just have this one thing. And what we need to do is grab the plan from here. So I should be able to just say cur plus equals plan get index, and that'll return a 0, 1, or -1. Oh, well, we have to care about -1s. All right, so if the key is we don't want cur to go negative, and I think if we make this a use size, we'll be able to at least see if it's going to go negative. And I think if I just put sum here, it should make all of these use sizes. Yeah. And then so I should be able to just change this stuff here to underscore and then add a new function called get. And that would return this stuff here. I guess what I could do, I could always pass in cur, and it'll return 0 if cur, yeah. But let's see. It's basically this, but different. Self-sequence index of this, and we want to return 1. Oh, yeah, maybe that's better. I pass in cur as usize and return a usize. And let's make this execute, maybe update. I don't know. There should be a better term for it. So we got to either return cur +1, cur -1, or cur. Right? And then down here, we don't say cur plus equals plan update. We say cur equals plan update. Doesn't like that because I got to pass in the current cur. There we go. And then this should be execute plan. And if we execute plan A, it should give us 1290. Tree execute plan. Oh, let's say execute plan. Execute plan. Loops. So we're going to do 10 loops. Still doesn't like it. Oh, because I have to pass in this. Ooh, we expected 1290 and we got 4350. Okay, so there's a bug somewhere. We're doing 2 loops around the track. It's saying it should be 1290. Did I do plan A? I did plan A. Okay, let's do 1 loop around the track and see what we get. See if it's 129. And if it isn't, that's our first bug. It's 165. So I guess what we just need to do is take a look at what's going on here. Println index, and then self track. And then we'll print out what cur turns into. And I messed that up. Oh, I got to print it out debug. Oh, it is starting start end. It shouldn't be. Oh, right, because I want you to do index +1. It's always so hard. And then I broke this already. Oh, I meant to do this. Okay. 129. Okay, that's better. That's better. Okay, so that was the bug. Right, and now we have to change this back to 10. So we got that right. So I think we're getting there. Now we just need to run the track with these lines, right? So we actually have to first put the plans together. Let plans is equal to lines, iter, map. I guess we could say vec plan. Line, bars, unwrap, collect. Right? And now we just run each plan on the track and then sort. So we do the same thing we did there for plan in plans. I guess we didn't need to do this. We could have done it the same way up there, but why not? We'll be a little different. Score is push, plan name, and track, execute plan. plan 10. And then we do the same thing here. We'll expect 3 arguments. I called it tree again. Yeah, this only takes 2 arguments. Oh, a number of loops? Yeah, there's the plan and the number of loops. Okay. All right. What is it telling me here? Argument 1 of track is missing. Oh, because I did that. That was silly. Okay. Run. Oh, we're not done yet. I guess we are done. Just change it from 1 to 2. And let's see if this is correct. Glitch in the quack tricks. Answer length is correct. I would hope so, but the first character is incorrect. Okay. So what did I do wrong? We care about well, let's run these other 3 plans and make sure that they are correct. Test plan B part 2. And it should be 3640. Yeah, that works fine. All right. So did I read? Oh, I did. I was about to say, did I read the wrong data? I did, in fact, read the wrong data. Okay. So it should be this. Hey, that's some quacking genius. That was kind of a bad mistake to make. Let's check in with Clippy. Ooh, Clippy has some suggestions here. Loop variable index is only used to index lines. That's correct. So I could do that. Right? Here's what it's saying is lines iter take lines len -1, skip 1, and then for each one, right, I can say last char. Oh, no, I can't. I can say line that. And then this just becomes line. And instead of rev next, use next back. Does the test still work? The test still works. Okay. That's fine. I'm okay with that. Anything else we want to do? Maybe I can just comment here saying this is a top line. Right side. Bottom. Reverse. And left side. Bottom up. Yeah? Okay. Good. Part 2 is done. And all we have left now is part 3. Let's take a look at our progress. Seeing all these gold things fall. I don't know what that's going to do. We have 2 stars on 7 now. Nice.